second half of section 7.1. Now we're going to simplify rational expressions. So we already said rational expressions are fractions. So we're still going to take fractions, but now we're going to simplify them. So this is exactly like it's reducing fractions is what this is. So simplifying rational expressions is simply reduce fraction. Oh, with a C. All right, reduce fractions. That's all we're going to do. And don't groan at me because it's not going to be that hard. Okay, here we go. So I want to give you steps. Here we go. When we're simplifying, step 1, this is going to be oh so much simpler if you will factor the numerator and the denominator. And you're going to say, oh, I don't need to do that. It's going to go quicker and easier, I promise. If you factor the numerator, factor the denominator, then you can easily and quickly see what matches and what doesn't. Because the second step is to divide out or to cancel any common factors. So if you factor it all out, you can quickly and easily see, ooh, this matches, this matches, this matches. I love it. I love canceling things out. It makes it all simple and easy. I love it. And then the last step is to multiply any remaining factors. So if you've canceled as far as you can go and there's still a few factors left, you just multiply those across, and there's your final answer. Let's do some. Here we go. All right. First one is 3x to the 5th divided by 15x squared. So we're going to factor these down to their simplest forms. So 3 is as factored as it gets because 3 is prime. So we'll leave 3 alone. And x to the 5th is going to be 1, 2, 3, 4, 5. And you might say, oh, this is tedious. It's okay. It's going to make it simple. Go ahead and write them out. You're going to put that over 15. And so you're going to need to do a little tree. And 15 is 3 times 5. And that's as far as it'll go. So just leave it 3 times 5. And the next squared is just x times x. All right. And then you're going to come in and you're going to say, well, these 3, so step 2, so that was step 1 is just factor it out. Easy. Step 2, now cancel anything that's exactly the same. They have to be exactly the same. So the 3's are exactly the same. Well, they're gone. These x's are the same. They're gone. These x's are the same. They're gone. So now the last step is just to multiply anything that's left. So we've got 1, 2, 3 factors of x, so x to the 3rd. Over, we just have a 5. So x to the 3rd over 5 is your simplified fraction, simplified rational expression. All right? If you think you got the hang of it, pause and do a couple do several of them on your own, all right? And see if you get them right. Or just work faster than me and get ahead, and then you can check and see how you did. All right, with this one, it's exactly the same way. The only difference is that you've got a negative sign in front of it, so make sure that you don't lose that negative. That negative stays in there. All right, so 4 is 2 times 2. And if you need to do a tree to figure that out and remember that, that's fine. So 4 is 2 times 2. And x squared is x and x. And that's all of our terms on the top. On the bottom, 28 is 7 times 4, and 4 is 2 times 2. So 7 times 2 times 2 is the 28. And x cubed is 1, 2, 3. So write them all out there so you see them. And now go in. Anything that matches is gone. 2's, x are the same. Now, what do you do in this case when there's nothing left on top? So is it 0? It's not 0 because that would be a different value. What we need is we need a placeholder, and the 1, remember, is our placeholder value. So don't lose your negative. Negative 1 over 7 and an x, or what's left. 1 over 7x is our simplified rational expression. All right? So don't lose your negative. If the fraction is negative to begin with, it's going to be negative at the end. And if you cancel everything out, in the denominator, then that means the denominator is 1, and so you don't even need to put it. Remember, if you have like 6 over 1, that's the same as 6. Remember that? So if you've got a 1 in the denominator, you can totally just leave it out. But remember, don't put a 0. That's not the same. Okay? So if it's in the numerator and you've canceled everything, your numerator is 1. If it's in the denominator, you can just leave it blank. Let's do a couple more. 36, let's see, I'm running out of room for making my trees here. 36 is 6 times 6. I'm going to do an upside down tree here. 2 times 3 and 2 times 3. So 36 is 2 times 3 times 2 times 3 times A, 3 B's, 1, 2, 3, and a C. All over. 54 is 9 times 6, and 9 is 3 times 3, and 6 is 2 times 3. So 3 times 3 times 2 times 3 times A and A times 1, 2, 3 B's. 1, 2, 3 B's. All right? Now go in and get rid of what's the same. Be careful that it's the same. So these 3's are the same. And here's 3's that are the same. And here's 2's that are the same. There's another 2, but I don't have any other 2's left. I don't have any other 3's. Here's A's are the same. 1, 2, 3 B's are all the same. So I think that's all that's left that's the same. So once you have them marked off, you can quickly and easily go through and see I have a 2 and a C. So my numerator is 2C. In the denominator, I have a 3 and an A, so 3A. 2C over 3A. Done. All right? Let's make it just a touch more difficult. Here we go. In this case, now the 9 we know is 3 times 3, and we've got times A times B. Now this, if we've got, be careful, if you've got a plus or a minus, now that changes things, okay? This isn't just 3 times A times 2 times 3 because this is not multiplied. This is added. So now when you're factoring out, now you've got to factor out using the parentheses like you did before. This is just a binomial. So you're going to take what is in common in the whole thing. And you can see, 3 is in 3 and 3 is in 6. So we're going to bring a 3 out. And remember what's left is A plus 2. You see where I did? So 3A and 2 times 3 is 6. Now, when you cancel out, you've got to be careful because these 3's will cancel. You're going to be very tempted to say, oh, look, I've got A's. Don't do it. Okay? Once you have a binomial, that whole binomial is the factor. In order to cancel out any part of that binomial, the entire binomial has to match exactly with a factor from the other, either the top or the bottom, depending on the opposite of where you are. Okay, so this A cannot cancel because this is an A and this is an A plus 2. All right, you understand? So don't do it. Okay, so what we have left now is 3AB over A plus 2 has to stay. All right? Let's do a couple more that have binomials so you can see what we're doing there. Let me make sure you can see this far down. Oh, yeah, we're good to go. Okay, so we're going to factor your numerator and your denominator here. So you look to see 2x squared and 8x. I know that 2 will go into 2 and 8. Don't forget to check your variables, and x will go into x squared and x. So a 2x is going to come out. And now let's look to see 2x came out, so we still have one more x factor inside. And then 8x came out, so that's going to be plus 4 because 2 times 4 is 8, and we already took the x out. All right, so far so good. Now let's look to see 3 will come out of 3 and 12, and x will come out. So take the x out, and then what you have left is 3x times another x plus 3x times a 4 gives you 3 times 4 is 12x. So I hope it doesn't confuse you that I'm going across this way. If you need to go down up and down instead of across, that's fine. I'm going across so that you can see that this matches, the numerators match and the denominators match. Okay, so now this is 2 times x and 3 times x, and you're multiplying those factors also. So now we can look to see the 2 and the 3 don't match. We can't cancel those out, but x and x match exactly. So we can cancel those out, and watch this. X plus 4 matches exactly x plus 4. It has to match exactly. If any part is different, even just the signs are different, those will not factor. But because they're identical, the entire binomial will factor out. And so now we're left with just 2 on top and 3 on bottom, or 2/3. Okay? Let that sink in while I erase. I've got one more for you. So factoring the numerator, factoring the denominator, even if it seems like it's simple, 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 go ahead and factor the whole thing. And then after it's factored, then you can start canceling. So I've got one more for you, and it is y squared minus 36 over y squared minus 2y minus 24. Okay, here we go. Now, the reason I'm doing this one is because now you've got binomials and trinomials that are going to need to be factored even further, okay? These are the ones that are factored into the 2 binomials. So if you'll look, sometimes it's easier to go like just below and just above if you can see it better. So the y squared minus 36, if you want to go straight across, you can. Sometimes what I do is I just kind of first, I go above it because it helps me because I usually go below. So if you want to space this out so that you can put these factored underneath and this factored underneath, that's fine too. Okay, so whatever way makes it easier for you to see the parts. All right, so y squared minus 36, y times y gives you the y squared, and 36 is negative, so I'm going to have one positive and one negative, and I need that middle term to drop out. So I need these terms to be the same so that they'll drop out, and 6 times 6 is 36. And this is where, if you got last chapter down and factoring is easy, then this is going to be a breeze. If you didn't quite get factoring, you want to brush up on that because this is going to be trickier, okay? The factoring is going to travel with us throughout the rest of this year, okay? So if you don't get factoring yet, you need to go back and brush up on that. Okay, so the outsides, negative 6y, positive 6y drop out. So I've got y squared minus 36. So we're good there. We're going to put that over this. And this one is a trinomial also, and there's nothing in common with all three. So I'm going to simply do my double parentheses. And I know y times y is y squared. And I know that my signs are different. And I want 24, so I want either 1 and 24, 2 and 12, 3 and 8, or 4 and 6. Whew! Okay, that's a lot, but I know that because I didn't have a number in front of the y squared, I can simply, because the signs are going to be different, I'm going to subtract to get a negative 2. So any of these that have a difference of 2, 6 minus 4 I know is 2, so I know I want the 6 and the 4. All right, did you see how I did that? All right, so now I know I want the bigger one to be negative because I want, when I subtract, I want to get a negative answer. So I want the 6 to be negative, and I want the 4 to be positive, and then I go back and I check just to be sure. Y times y is y squared. Positive 4 times negative 6 is negative 24. Negative 6 plus 4 is negative 2y, and that's what I have in the middle term. So now I'm finished with my factoring. Once I've factored, now I look for, now be careful, I can't factor out this y, I can't factor out these 6's, but this whole y minus 6 matches this whole y minus 6. So this entire binomial will factor out, and those will cancel each other because they're identical. The whole binomial has to be identical in order to cancel that out. So now my final answer is y plus 6 over y plus 4. And you can put those in the parentheses or not. Either way is fine. All right? Whew! Easy sneezy. Easy, easy, easy. The hardest part is the factoring. Once you've got them factored, then it's fun because you're just starting to cancel. So don't forget, factor the numerator and the denominator, cancel any of the common factors, and then multiply anything that's left. And you're done. All right, see you next time.